or hold closed the main contacts. The tripping mechanism is the device that releases the holding means and opens the main contacts. In most cases, the opening force is furnished by springs that are charged by the closing mechanism. The closing mechanism is a solenoid coil, springs, or a motor and gear arrangement. The closing force serves to close the main contacts and at the same time charges the opening springs. The lockout mechanism is the device that locks the main contacts in the open position following the completion of the sequence of operation. Interrupter. The interrupter is the part of the recloser that contains separable contacts which operate within an interrupting unit. The physical configuration and method of interruption varies with manufacturer and recloser classification. Control. Reclosers are provided with sequence control devices and operation integrator to change the recloser from instantaneous operations to time delay operations and to lock out the recloser after a prescribed number of operations. Individual tripping operations of a recloser can be made to follow instantaneous or time delay, time current characteristics. There are a number of different sequence control devices that may be roughly classified into three types. Hydraulic type is an oil pump attached to the recloser plunger which raises a trip piston a certain distance with each operation of the recloser. This trip piston establishes the sequence of fast and delayed tripping operations and eventually locks the recloser open. Mechanical type is a mechanically operated trip piston which lifts a rod one notch at a time to accomplish sequencing. Electronic types of control utilize solid-state circuitry to provide the intelligence for performing all of the command functions for automatic operation. Operation. When an overcurrent of sufficient magnitude flows through the trip coil, the tripping action is initiated and the contacts are opened. The recloser contacts then reclose following a predetermined length of time. By the time the recloser has reclosed the circuit, the sequence control device has moved to count the trip operation. If the fault still persists on the circuit when the recloser closes, the tripping and reclosing sequence is repeated a predetermined number of times as established by the sequence control device until the recloser goes to lockout. If the fault has cleared from the circuit during any open circuit period, the recloser closes and remains closed. The sequence control device resets so that it is in position for the next sequence of operations. Manual tripping. An automatic circuit recloser can be tripped manually by moving the manual operating handle to the trip position by means of a hot stick. Manual closing. An automatic circuit recloser can be closed manually by moving the manual operating handle to the close position by means of a hot stick. Manual reclosing after lockout operation. Many reclosers in service are designed to lock out following a selected sequence of tripping and automatic reclosing operations. The theory behind this type of application is that if a fault is temporary, it will be cleared during the instantaneous operation of the recloser. If the fault is permanent, the recloser goes into time-delayed tripping operation and permits sectionalizing devices, such as fuse beyond the recloser, to open and isolate the fault. If a permanent fault should occur between the recloser and the next sectionalizing device out on the line, the recloser then goes to lockout and isolates the fault. Load pickup. The inrush current experienced in closing a recloser after a lockout operation may occasionally introduce some difficulties in getting the recloser to latch closed. The highest inrush current can originate from automatic starting motors, are magnetizing current of transformers. However, these types of inrush currents are normally short-lived. Some makes of reclosers may operate on the instantaneous trip due to this inrush current and may have to open and automatically reclose until the sequence of operation comes to the time-delay trip before the recloser will stay closed. Caution: arbitrary changes in sectionalizing devices by operating personnel should not be done. Fuse links should be replaced by a link of the proper size and make. Changes in recloser size or setting should not be made without the consent of the system protection engineer. Indiscriminate changes in a sectionalizing coordination scheme can render the overcurrent protection ineffective and may even subject lines and equipment to damaging conditions. Review: this video has presented material to improve your understanding of the application and operation of an automatic circuit recloser. Many complex ideas were presented. If it is necessary, review this video as many times as needed until you clearly understand all of the material presented. With the correct application and operation of automatic circuit reclosers, a utility will minimize outages to the consumer, minimize outage expenses, minimize damage to primary lines and apparatus during faults, minimize hazards from high voltage to the general public.